The basal ganglia modulate movement using two pathways, the direct pathway, which facilitates movement, and the indirect pathway, which inhibits movement. Dopamine from the substantia nigra pars compacta stimulates movement by activating D1 receptors of the direct pathway and inhibiting D2 receptors of the indirect pathway. In the direct pathway, the GPI is normally inhibitory to the thalamus. D1 activation inhibits the GPI, reducing its inhibitory output. This inhibits the inhibition, allowing the thalamus to activate the motor cortex and produce movement. Failure of the direct pathway occurs in Parkinson's disease. Loss of dopaminergic input prevents activation of D1 receptors, so the GPI remains uninhibited and continues to suppress the thalamus. The indirect pathway becomes relatively overactive, leading to difficulty initiating movement. In the indirect pathway, the GPE normally inhibits the subthalamic nucleus. D2 activation inhibits the GPE, releasing the subthalamic nucleus from inhibition. The subthalamic nucleus then excites the GPI, increasing thalamic inhibition and reducing movement. Failure of the indirect pathway occurs in Huntington's disease. Loss of D2 expressing neurons prevents inhibition of the GPE, so the GPE overinhibits the subthalamic nucleus. With the subthalamic nucleus suppressed, the GPI becomes underactive, the thalamus becomes disinhibited, and excessive spontaneous movements such as chorea occur. In summary, dopamine promotes movement by stimulating the direct pathway and inhibiting the indirect pathway. Parkinson is loss of dopamine causing reduced movement. Huntington is loss of the indirect pathway causing excessive movement.